Hello everyone. There is a lot being said by researchers about the possibility of terraforming various planets. But before starting such a large-scale project, people must reach the planet first. Once there, they will face all kinds of problems. For example, problems with the functioning of the spacesuit. Even if you went to any planet in our solar system other than Earth right now, you would only survive for a short time anyway. But it should be great fun. Thank you all for watching this channel. So, we'd like to talk about what exactly awaits us when teleportation actually takes place. Or, if you are astronauts and something goes wrong with your spacesuits, how much time do you have to return to the space station in comfort? Okay then, let's get started. Mercury. Mercury has almost no atmosphere. Therefore, temperature differences are very large on Mercury. In the daytime hemisphere without a spacesuit, a human being would burn, and in the nighttime hemisphere, he or she would freeze like an icicle. Moreover, Mercury rotates very slowly around its axis of rotation, so humans will not be able to greet the dawn or dusk. It is said that the average time a human can survive on Mercury is about 90 seconds. As with any spaceflight, one must close one's eyes and exhale heavily to minimize damage to the body. In fact, the atmosphere pressure on the surface of Mercury is almost zero. In such an environment, the water in the eye can boil, the air in the lungs can rupture out of the body, and the alveoli can rupture. We have had enough of such horrors. As you can already see, Mercury is not a very comfortable planet to live on, and damage to your spacesuit can cause serious injury. Mercury has permafrost, deep craters that are never exposed to sunlight. Temperatures on its slopes are Earth level, as in the evening darkness zone. But even with this, the problems caused by the absence of an atmosphere cannot be helped. Venus. Of all the terrestrial planets, no one comes near Venus when it comes to meanness. When you go to Venus, you are confronted with a large number of choices. You have the special option of burning at about 500 degrees Celsius, or being melted in a rain of sulfuric acid, somewhere between sugar in your tea and a snowman, or even suffocating to death due to the immediate cessation of your respiratory center. In most countries, health and sanitation standards dictate that the concentration of carbon dioxide in the air must be less than 0.5% in work areas and 0.2% in residences. When carbon dioxide concentrations rise 2 to 4% or higher, autonomic nervous system dysfunction occurs, causing symptoms such as lethargy, drowsiness, and fatigue. Above 10%, a person may lose consciousness and die from hypoxia. Above 20%, death occurs instantly due to cessation of function of the brain's respiratory center. On Venus, sanitation personnel faint. What is worse, they lose consciousness in an instant without waiting for the results of measurements. The carbon dioxide concentration on Venus is about 98%. Drops of acid rain mercilessly rain down on the bodies of these brave personnel. The atmospheric pressure on the surface of Venus exceeds 90 atmospheres. Venus's atmosphere is as thick as an arrowroot starch gruel, and the entire planet is covered in a kind of semi-liquid ocean. But Venus also has real oceans. As you might expect, it is a sea of sulfuric acid. But even if you wear a spacesuit, you should not go to see this ocean. Under this kind of pressure, the wind is like a wall rushing toward you. In short, on Venus, you are lucky if you can survive for even more than 1 second. At a height of a few kilometers in the sky, however, things are a bit more fun. There, the temperature and pressure are about the same as on Earth. Even in skies above Venus, it is still very dangerous to lose your spacesuit, but you will not die instantly. Astronauts may survive for a few seconds or so, while their colleagues respond back. Mars. The atmosphere of Mars is so thin that a person landing on Mars without a spacesuit can stay alive for about 1.5 minutes, about the same as on Mercury. It takes 15 seconds for the eyes and lungs to be damaged. There are always ways to extend this time, as I told you. Also, the Martian atmosphere contains a very high concentration of carbon dioxide, but the atmosphere is so dilute that even if you take a deep breath, it cannot enter your alveoli. There is not enough partial pressure to pass through the alveoli. Therefore, astronauts do not have to worry about instant death. Summer temperatures at the Martian equator are about the same as Earth's temperate climate, about 20 degrees Celsius. This is comfortable for humans, and there is no danger of overheating or frostbite. This is also the reason why Mars is the most likely candidate for terraforming. Ceres. The largest asteroid, Ceres, which was elevated to the classification of quasi-planet in 2006, has almost no atmosphere. Thus, the length of time humans can survive on Ceres is about the same as on Mercury or Mars. Moreover, Ceres is cold, with temperatures never exceeding -270 degrees Celsius. It receives only a fraction of the heat from the sun. The same is true for other asteroids in the same asteroid belt as Ceres. These asteroids would be too small to bother colonizing. These instead have potential as sources of rare Earth-bearing ores. All of this is also true for other quasi-planets such as Pluto, Eris, and other solar system bodies. The environment there is not much different from the environment in outer space. Jupiter and Saturn. Jupiter and Saturn, the closest giant planets to Earth, are very similar to each other. Because the surfaces of these planets are not solid, it is difficult to say we've landed on Jupiter. Given the sea level, i.e. the height where hydrogen and helium do not vaporize due to the atmospheric density of Jupiter and Saturn, astronauts would die instantly from the pressure, and even spacesuits would not protect against it. On the higher clouds of Jupiter and Saturn, where the atmospheric density is about the same as on Earth, they can live a little longer, because there is nothing there to crush you. But another problem remains. First, they cannot breathe. The atmosphere of a giant gas planet is a horrible mixture of methane, carbon dioxide, and hydrogen. If you breathe even one breath of this stuff, you risk death. If you hold your breath, you will be able to hold on for a minute or so before the toxic fumes soak through your skin and poison you. Secondly, there is the question of gravity. Gravity on Jupiter and Saturn is about 11 times greater than on Earth. One must not forget about Jupiter's other characteristics. Jupiter has very strong radiation, so much so that you can be exposed to lethal doses of radiation in no time, even if you are on a satellite. And there are intense winds and violent storms. Saturn is a little better in this regard, but it is still by no means a suitable place for life. Uranus and Neptune. Olaf Stapledon, the great British science fiction writer of the 1930s, who wrote such works as The Last and First Humanity and The Star Maker, predicted numerous discoveries and was the first to discover a variety of outlandish ideas, for which he is highly regarded by Arthur C. Clarke and George Lucas. The Last and First Humanity describes, among other things, life on Neptune for the remote descendants of humanity. At the time, Neptune was thought to be similar to Earth, only heavier and colder. Therefore, it was assumed that as the sun became more active, it would be a planet fit enough for life in billions of years' time. The genius who created good old science fiction was, unfortunately, wrong. Neptune and Uranus are now classified as giant ice planets, which do not have solid surfaces, are smaller than Jupiter and Saturn, and are very cold. Almost everything we have said about Jupiter applies to these planets as well, with one exception. It is so cold on Neptune and Uranus that it can become a new problem. But in the upper atmosphere, it is quite possible to survive a few minutes or so until help arrives. Let's say goodbye for today. Thank you all for watching. I hope that none of you are planning to leave the Earth in the near future. I would not want you to go if possible, but if you still decide to, please get bundled up, eat well, and breathe only in your spacesuits. We await your return. See you again. Goodbye.